In this video, we will discuss and illustrate the rules in differentiation. Let's have the first rule. The constant rule. If f of x equals c, where c is a constant, then f prime of x equals 0. Or the derivative of a constant is equal to 0. So let's have an example. If we have f of x is equal to 3, 3 is a constant, therefore the derivative of this function is equal to 0. Let's have another. If we have f of x is equal to 5 pi, so this is also a constant, so f of prime of x is equal to 0. In short, the derivative of a constant is 0. Let's have the second rule, and this is the power rule. If f of x is equal to x raised to n, where n is an element of natural number, then f prime of x is equal to n times x raised to n minus 1. So how's this? So let's have an example. So if f of x is equal to x to the fourth, so let us use this rule. So f prime of x is equal to, so this is our n, so 4x raised to 4 minus 1, so n minus 1. So it is equal to 4x cubed. So this is the derivative of our given function. Let's have another. So if we have f of x is equal to 1 over x to the fifth, so we can express this function as f of x is equal to x raised to negative 5. So using this power rule, we have the derivative, which is equal to negative 5x raised to negative 5 minus 1. So, and this is equal to negative 5x raised to negative 6. Then, if we want to express the negative exponent in positive 1, we have f prime of x is equal to negative 5 all over x raised to 6. Okay. Another one, if we have f of x is equal to square root of x, so we can express this as x raised to 1/2, and then if we can use this power rule, we have 1/2 x raised to 1/2 minus 1. So we have f prime of x equals 1/2 x raised to negative 1/2. And then, so we have, so if we want to express this negative exponent to positive exponent, we have 1 over 2 x raised to 1/2. And then, we can express this x raised to 1/2 as 1 over 2 square root of x. Okay? And that's how we use the power rule. So let's have the third one. We have the constant multiple rule. So if f of x is equal to k times h of x, so our function here is h of x, where k is a constant, then f prime of x is equal to k times the derivative of h of x. So let's have an example. So if we have f of x is equal to 3x to the 4th, so we have constant here. So we can determine the derivative of this by f of x equals 3 times the derivative of x to the 4th is 4x cubed. So using the derivative of the power rule. So f prime of x now is equal to 3 times 4. So we have 12x cubed. Okay. So this is now the derivative of the function. If we have f of x, another example, negative 3x to the negative 4. So using the derivative of the power and constant multiple rule, so we have f prime of x is equal to negative 3 times derivative of this is negative 4x raised to negative 5. So we have negative 3 times negative 4 is 12x to the raised to negative 5. Then we have 12 all over x to the 5th if we want our exponent to be positive. Okay, the next one is the sum and difference rule. So if f of x is equal to g of x plus h of x, so here, so there are two functions where g and h are differentiable functions, then f prime of x is equal to g prime of x plus h prime of x. Meaning, so the derivative of this function is equal to the sum of its derivative. So let's have an example. So we have if f of x is equal to 3x squared minus 2x plus 5. So as you can see, we have 3x squared. We can have this as our g of x, h of x, and m of x, or we have three functions here. So let's have the derivative of each of these three functions. So then the difference of these two functions, and then we have plus here, so we have the sum and difference. We can use the sum and difference rule here. So using the power rule, so we have 3 times 2x minus 2. Derivative of this is x 1 times x raised to negative 1 minus 1 plus derivative of 5 or constant is 0. So we have 6x minus 2 times derivative of x is x raised to 0, and that is 1 plus 0. So we have 6x minus 2 is the derivative. So if we have another f of x is equal to 3x raised to negative 2 plus 4x cubed minus 2x squared plus 5. So let's find the derivative of this. So we have 3 times negative 2x raised to negative 3, since we have minus 1 here, plus 4 times derivative of x cubed is 3x squared minus 2 times derivative of x squared is 2x. Since 2 minus 1 here is 3 minus 1, that's why it is 3x squared, plus the derivative of the constant is 0. So the derivative now is negative 6x raised to negative 3 plus 12x squared minus 4x. And then if we want to express this negative exponent to positive exponent, we have negative 6 all over x cubed plus 12x squared minus 4x. And this is now the derivative of the given function. Okay, let's have the product rule. If f and g are differentiable functions, then the derivative of y with respect to x is equal to f of x times g prime of x plus g of x times f prime of x. Meaning, so to get the derivative of the product, we have to multiply the first function times derivative of the second plus the second function times the derivative of the first. So let's have an example. If we want to determine, let's have the black pen. So if we have f of x is equal to 2x plus 3 multiplied by 3x minus 5. So as you can see, we have two functions here. We have 2x plus 3 and the other one is 3x minus 5. And using this rule, so we have f of prime of x is equal to, we can also use the first times the derivative of the second plus the second times the derivative of the first. So this first is the first function and s is the second function. So meaning we have the first function, we have 2x plus 3 times the derivative of this second function, and the derivative of this 3x minus 5 is 3, since the derivative of the constant is 0 and the derivative of 3x is 3. And then plus The second function, our second function is 3x minus 5 times the derivative of the first function, and the derivative of the first function is 2. Then we have to simplify. So using distributive property, we have 6x plus 9 plus 6x minus 10. Combining like terms, we have 6x plus 6x is 12x. Then positive 9 and negative 10, we have negative 1. So this is our derivative of the given function. So that's the product rule. Then let's have the quotient rule. If f and g are differentiable functions, then the derivative of f of x over g of x is equal to the g of x times the derivative of f prime of x minus f of x times derivative of g prime of x all over the square of g of x. So meaning the derivative of the quotient is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the square of the denominator. So as easy as that. We can also use this formula. So the derivative of f of x over g of x is low d high minus high d low all over low square, and low pertaining to the denominator and high is the numerator. So let's have an example. If we have f of x equals 2x minus 3 all over 3x plus 2. So we have the numerator and the denominator. So let's apply the rule in finding the derivative. We have low, or the denominator, this 3x plus 2 times the derivative of the numerator. So the derivative of the numerator is 2 minus, so this is minus the numerator, and that is 2x minus 3 times the derivative of the denominator, and the derivative of the denominator is 3 all over the square of the denominator. So we have this one. So let us simplify. So we have 3x times 2 is 6x. 2 times 2 is 4. Minus, we have 3 times 2x is 6x. Then minus 9. So all over 3x plus 2 squared. Then we have 6x plus 4. Then we have to distribute this negative. So it becomes negative 6x. And this is negative times negative is positive 9. So all over 3x plus 2 squared. Then it follows that, so 6x, this is 6x, and then we have negative 6x, so cancel. So the remaining expression is 4 plus 9, and that is 13 all over 3x plus 2 squared. So therefore, the derivative of the function is 13 all over, if you want to expand this, we have 9x squared plus 12x plus 4. So this is the derivative. So always remember that the derivative of f of x over g of x, or the quotient rule, is low d high minus high d low over low square. Meaning, low times derivative of the high minus high times derivative of the low over low square.